Hey everybody. So today we're going to look at our second day of conditional probability, and we're going to be focused more on using the formula today. Even though we used it the first time, it's a little different here. So understanding a two-way table and conditional probability allows us to develop a general rule for conditional probability. And we've said the probability of B given A is A and B over A, or A given B is A and B over B. Generally, this is the second form here is the one that I will write. So if you want to use that you can. So question 1 says the guidance department has reported that of the senior class, 2.3% are members of the Key Club, and they're going to denote that as K, and then 8.6% are enrolled in AP Physics, they're going to denote that as P, and 1.9% are in both. Now, first thing you want to remember is we don't really want to work with with percents here, so we're going to go with proportions. So 0.023, 0.086, 0.019. So it says determine the probability of P given K. So find the probability of P given K to the nearest tenth. So first off, let's take a look at what this means. It says what's the probability that a student is enrolled in AP Physics given that they're a member of the Key Club. So here we go. Let's take a look. So really what I like to do is, it doesn't really matter. You can replace it with A and B, but really we're just going to use this formula right here for this. So it's the probability of P and K over K. So it's really what it's saying is out of those in the Key Club, how many are also in AP Physics? So let's see if we have this information here. Well, the probability of K that a member is a member of the Key Club is 8.6%. 8.6% of all seniors are in the Key Club. So that's going to be our denominator, 0.086. And then the numerator, probability of P and K, well, let's see, 1.9% are in both. So that's 0.019. So what it's saying is out of the 8.6% of kids that are in Key Club, what percentage of that 8.6% is part of also AP Physics? So we take our calculator and we calculate this and we get 0.019 divided by 0.086 and we get 0.22, which rounded to the nearest tenth of a percent. So 0.2209 is 0.221, which becomes 22.1%. Now, this next part I really like, being the AP stats teacher, is the principal would like a basic interpretation of what this means. Write a statement relating your calculated probabilities to student enrollment in the given situation. So I'm going to actually type this out. I'm going to write. I'm going to write, if we know a senior is in the Key Club, there is a 22.1% chance that the student is in AP, cancel physics. Okay, so let's kind of take a look at what it says. Again, it's given that we know they're in Key Club, so we say, okay, you're in Key Club. Now what's the likelihood that you're in AP Physics? Well, 22% chance about. Now think about that. That's different than if you just take a student and don't know anything about Key Club. Only 8.6% of kids are in physics, but if you're in Key Club, 22% of kids are in physics. So you're more likely to be in the Key Club. You're more likely to be in AP Physics if you are given that you are in the Key Club. Okay, so let's look at one or two more problems. A study was designed to test the effectiveness of a new drug. Half of the volunteers received the drug. The other half received a sugar pill. The probability of a volunteer receiving the drug and getting well was 40%. So the probability that they got the drug and got better, 0.4. What is the probability of a volunteer getting well given that the volunteer received the drug? Well, what's the probability they received the drug? How do we know this? Does it really give us this? It looks like it's not enough information, but half of volunteers got the drug. So the probability that you did get the drug, 0.5. So they're asking now, what's the probability of a volunteer getting well given that they received the drug? So getting better given that they got the drug. So that is, let's see, that's the probability of better N drug over drug. So that is 0.4 over 0.5. And we get 0.4 divided by 0.5, and that's 0.8. So what is that saying? That's saying that 80% of those that got the drug got better. That's pretty good. The probability of that a resident of a housing community opposes spending money for community improvement on public issues is 0.8. Probability they oppose is 0.8. The probability that a resident favors spending money on improving walkways given the resident. Now it's saying the probability that a resident favors spending money on improving walkways given that the resident opposes. Oh, it's two different. Sorry. Okay, let's read that again. I apologize. The probability that a resident of a housing community opposes spending money for community improvement on plumbing is 80%. 80% of people don't want to improve plumbing. The probability that a resident favors spending money on improving walkways, that's different, given that they oppose the plumbing, is 0.85. Determine the probability that a randomly selected resident opposes spending money on plumbing and favors spending money on walkways. So now they're giving us the conditional. So remember, the probability of A given B is A and B over B. So if we look at that here, that is 0.85 equals, we don't know, favors and favors the sidewalk and oppose plumbing, but we do know that those who oppose plumbing is 0.8. So now we could solve. Cross multiply, put it over 1 and cross multiply, and you get the probability that they favor fixing sidewalks and oppose fixing plumbing. Let's cross multiply, 0.8 times 0.85. 0.68. All right, try the homework, and we'll talk soon.